So we're just going to look at conjugates and properties of conjugates, and then we'll just have a look at one example of how it can help us with some proofs. The modulus of a complex number is the same as the modulus of its conjugate. They are a reflection of each other. Remember, in the x-axis, so the distance to the origin would be the same. Speaking of the reflection in the x-axis, that means their arguments will be the same size. One will be positive, one will be negative. Z times Z conjugate, which we were saying is the real part squared plus the imaginary part squared, which it is, that is certainly true. But now we can say it's the modulus of Z squared. And we saw these properties: adding, find the conjugate first, then add, or add first, then find the conjugates. Same with multiplication, same with division. And if you want to find the reciprocal of a complex number, the conjugate over the modulus squared. So here's this example we're going to look at. X plus iy is the square root of 6 plus 2i and 3 minus I. Show that x squared plus y squared is equal to 2. Now, of course, yes, we could actually go and work out what 6 plus 2i divided by 3 minus I is, and then from there show the real part squared and the imaginary part squared, and do that. But let's play around with conjugates. So x plus iy is the square root of 6 plus 2i and 3 minus I. So if I square that, I'll get rid of the square root sign. But if I take the conjugate of both sides, that must also be true. Now we play with the conjugates. Well, the conjugate of the division, remember, I can do it in any order. So that's the same as the conjugate of 6 plus 2i over the conjugate of 3 minus I. And the conjugate of x plus iy squared would be the same as x minus iy squared, if I do the conjugate first. So now what I'm going to do is multiply these two things together. Because on the left-hand side, I have the difference of two squares squared, but because it's an imaginary number there, it's actually going to be x squared plus y squared squared. And on the right-hand side, I've just got the conjugates multiplied by each other. So we end up with x squared plus y squared squared is 6 squared plus 2 squared over 3 squared plus 1 squared, which turns out to be 4. Therefore, x squared plus y squared is 2. Now, I know it has to be positive 2, because remember, x and y are representing real numbers. And when you square a real number, you've got to get a positive number. So negative 2 would not be a possibility for this one.